Hi everyone, how you doing? And a very warm welcome back to Project Rio Part 4 here on youtube.com/Wi-Fi Sheep with me, Tom. Now, before I continue, just a reminder, if you are watching this video right now and it's before November 2024, then I will be appearing at the Retro Computer Festival in Cambridge, England, being held on Saturday the 9th of November and Sunday the 10th of November 2024 at the Centre for Computing History in Cambridge, England. It is going to be a fantastic show. If I show you here on the website, you can see it's saying it's going to be the biggest yet, with more exhibitors than ever before. I'm going to be, hopefully, and should be exhibiting for both days. So I'll be there on the floor with a number of different topics, including the conclusion to our Going GUI series, which we are also running at the moment here on the channel. One thing I must stress, and I say this every time like a stuck record, but I'll say it again, is you must pre-book. This is going to be packed and oversubscribed. So please, please, please get onto the website now. Details are on screen right now and also in a link to this video. Support the museum and pre-book your tickets for either one day or both days, and I really, really hope to see you this November in Cambridge. So a warm welcome back to Project Rio right here on youtube.com/Wi-Fi Sheep. This is the series where we are building a colour 8-bit programmable computer. If you don't know what I'm talking about or have only just seen this video, do go back and watch the very first video in this series, or go all the way back and watch the very first of our Tiny Basic Computers series that was the forerunner of what we're now doing with Project Rio. So this is part 4, and I'm going to split part 4 into 2 sections. This will be part 4a, and there'll be a follow-up video, part 4b. If you want to join in with this project, you need to join the Project Rio downloads tier on Patreon. You can find that again in the description of this video, or by going to patreon.com/Wi-Fi Sheep. There's now a button called Collections, and on there you'll find the Project Rio collection page, which will then give you the downloads you need. If you are building along and you've been waiting a couple of months for me to get back to it, then once again, thank you so much for your patience. So the first thing we need to do is actually check our system is still running from last time. So here is the basic setup as we had it for a Project Rio Tiny Basic system. It's powered by an off-the-shelf Arduino, or in this case clone Arduino Mega 2560. We're using the 2560 as the main 8-bit processor. For graphics and also USB keyboard handling, we are using a Raspberry Pi. Any kind of Raspberry Pi will do, although the Raspberry Pi Zeros, or in this case the Raspberry Pi Original Model A or Bs, are absolutely fine for this, as we are purely running these as a dumb terminal. And on the SD card here we have Pi GFX, which is a bare metal terminal program specially for Raspberry Pi, which means that the Raspberry Pi doesn't run any overhead operating system. It is purely acting as a terminal and graphics interpreter. And then finally here we have a breadboard, which we have a level shifter because we need to drop between 5 volts TTL logic on this board over to 3.3 volts for the Pi. If you try to plug the pins from an Arduino straight into a Raspberry Pi, it will damage the Raspberry Pi as it runs on a lower voltage. Hence we have the level shifter to shift the signals back and forth between the two. We added a speaker for sound, or a buzzer in this case. And last time we added micro SD card support with a micro SD card, which is we're using as storage medium to actually store our files, or our basic ASCII encoded files on. And this SD card is separate to the SD card in the Pi, and as I've already said, the Pi one is purely to drive the graphics card software on the Pi. It's not related to the rest of the system. So hopefully your system is still intact and all working fine from the last video. And the first thing to do is a quick power up. I've forgotten how loud that was, to make sure everything's all right. Now remember, we were powering from the Raspberry Pi, and then we were jumping power straight to power up the Arduino. So that sounded promising. I've got the HDMI lead here out the Pi connected via a capture card. So let's just check. And there we go. We've now got the boot screen. The current version, by the way, you should be running for the kernel, which it reports there on the boot screen, is 5.7.1 mega build. If you have a number that is less than that, then you need to update your firmware, and we showed how to do that last time. You'll need the Arduino IDE, as the source code file or the sketch is now available, and you just compile and upload the sketch. We showed that last time, so that should be, it's pretty self-explanatory. Any questions on that, happy to answer in the comments. So in today's video, we're going to look at adding another type of control or input device. Now, at the moment, we've been solely using the USB keyboard, or we've been connecting via USB into another machine and then running something like PuTTY or Minicom as a terminal emulator to send ASCII characters or instructions over serial to the computer system. This time what I want to do is add a joystick. And I've actually got a joystick here, the type I want to use. Here it is. This is a clone of an Atari 2600, an original Atari 2600 controller. You could use the originals, although they're getting on 50 odd years now. This is a relatively cheap, inexpensive Chinese clone controller, but it has to be compatible with the 2600. And it has to have here, if I show you on the other camera, we need to have one that has, there we go, this type of plug. This is called a DB9 type plug. And this is the standard that we are going to use for Project Rio. Some other controllers like Genesis controllers and some mice and other things do actually still use this pin standard. Those don't work with this system. It has to be wired as the Atari standard, and that's what we're going to use. So we will be using this single button joystick, and we're going to interface this with our Project Rio system in order to give us some joystick based control of applications and software and stuff that we may want to develop and write on the system. So as well as the main controller or joystick itself, you're also going to need one of these. Now these are pinned out DB9 based connectors, and this is the male connector as the socket. And I got these the wrong way around when I ordered stuff originally, as the sockets are always female. So it's female on the controller side and the computer needs to be the male side, and we're connecting like that. What's really nice about these is, as you can see, they've actually got all the pins broken out. Now you can just wire straight to the pins if you want. These with screw terminals are a little bit easier to work with, and this is the standard we're going to use for Project Rio. You can get these relatively inexpensive off eBay, AliExpress, etc. The same with the controllers, they're not very expensive. You don't need proper branded Atari ones, you just need something that is going to be compatible with the original 2600. And the third thing we need is we need some male-to-male ribbon cable. And again, you can buy these relatively inexpensive. And we're going to need 6 cables, so you can just peel off 6, which I have done, and I have here. It's useful when you peel these off if you can have at least one black cable, as that will indicate the ground lead, and it's a little bit easier to wire it up. And that's all we're actually going to need to add a joystick to our system. Okay, so the controller itself, or the joystick, is going to tap directly into the Mega 2560 board. So we're not going through or needing to interface with the Pi side. And although it's a little bit of a mess of wires, if I try and move some bits around so I can just show you on camera, move that out of the way. There we go. Right. So we're going to connect directly into the digital pins, which are along here and are sometimes labeled as digital. In this case, they're not, but they're opposite to what's labeled as analog, which are labeled as A over here. These might be labeled as D, or in this case, just be as straight numbers. So in our system at the moment, D5, I think it is. Yes, D5 is already in operation, and that's been used for the sound. But the other pins are clear, And so we have enough I/O logic to be able to wire in our joystick. I will make available in the download section of the Project Rio Patreon a wiring diagram that explains exactly what I'm going to do here, as well as the other wiring diagrams, which I appreciate haven't actually been put online yet and may be quite useful for those of you that want to recreate this particular system. Anyway, so what we'll do is we'll start with the ground, and ground is 8. So black into 8, and then with a small double head screwdriver, I'm just going to turn that down, and that's now clamped on quite nicely. So that's the first terminal 8 done. White, which I don't have here, so I'll use green instead, is on 6, and that's the fire button. So that is equivalent to pressing that button, be identified by this wire. So that goes on to 6. Again, it can be a bit tricky, but if you can get them to go all the way in, that's great. And then just tighten the screw, and that's on. Up, which is pushing up on the joystick, is red, and that wants to go into pin number 1, so that's round the other side. That's here. That's great. Orange, which is down on the joystick, is going next to it onto pin 2. Brown, which is left, is going on pin 3. And yellow, which is right, is on pin 4. Okay, so that's really easy just to wire in, and that's the connector now wired on that side. So now we have to do is the wires corresponding on the other side. So black is going to go on to ground. Ground is 1, 2, 3, 4 in. It's a little bit confusing on the silk screen, but because the silk screen, I don't know if you can see that, gets a little bit crowded up the top, but ground is 4 down. D10 is the white wire, which is fire. Red is going on D9, which is next to it. Orange, which is down, is going on D8, next to it. Brown is going on to D12, and brown is left, so 12 is 10, 11, in the middle there, 12. And D11, yellow, is right, so that's going to squeeze in between. In this case, what I'm saying is white, but it's actually our green and our brown, and yellow's going in the middle, like so. There we go. Okay, so it starts to get a little bit congested, but they should all now be in the right pins. The nice thing about this setup is it detects the grounding, not the voltage. So it pulls the pins down to detect a movement, which means you're not having to run a 5-volt line through the controller. It's literally detecting if these pins are pulled to ground, hence why it's pulled low rather than high. So even if the wiring is not correct, it shouldn't do any damage. Or even if you plug in a device that's got the same connector but isn't compatible, because there's no power, no voltage, it shouldn't damage anything. It's not like we're running an incorrect line voltage through the controller. So the next thing we're going to need is some actual software to drive our joystick and also to test it. And that's where a new folder included on the Project Rio Patreon downloads comes in. If you click the downloads link in the Project Rio Patreon, it'll take you through to this Google Drive, and many of you will have seen this before. This is the drive that contains all the Project Rio software, drivers, code, and also a version of Tiny Basic computers for colour compatible with the ESP32, if that's something you want to play with. Now, looking at this directory, and this might change a little bit by the time you actually look at it to what I've actually set up for the video, but looking at this directory, if we click on this top folder here, there's a new folder called Rio Shell, and at the moment it's version 002. If we open Rio Shell, there's a series of BAS encoded text files. This is for the new, well, what was going to be called Rio OS, but is now going to be called Rio Shell. And this is a graphic user interface shell for the Project Rio system. This is now available to all Patreon backers. I will stress it is in very, very early development, hence it's 002 alpha, and it does have some major issues and flaws and stuff which I intend to fix, especially as I want to show this as part of my Going GUI series and take Project Rio to Cambridge in November 2024. With your system powered down, take your microSD card out, put that into your PC, Mac or Raspberry Pi, whatever it is you're using, and then go back to the Rio Shell version 02 or later. And what you need to do is download and copy all these files and save them to the root directory of the micro SD card. Don't just download the folder and shove the folder onto the micro SD card. That won't work. You actually have to, you can by all means download the folder, but you need to extract the contents and then individually or as a group copy these files onto the root directory. Don't put the folder on the SD card. Okay, once you've got that done, we can put the microSD back in. Let's make sure we actually plug in our joystick. Okay. Put that on camera so you can see it. So this is the new setup we've got. Also, I need to add a keyboard because I will be doing some typing. So again, just a little USB keyboard, which I'll just have off camera. But we'll just plug that straight into our Pi. Okay, so now let's power back up the system. Looking good. I've forgotten how loud that is every time. Okay, so we now have the main basic prompt here of the current Project Rio system. As long as it doesn't say SD card error, which mine doesn't, it should have picked up and read the SD card, which is great. So now what we can do is we can run a small program which we've now installed on the SD card as part of the Rio Shell suite, and we can use that to test that the joystick is actually working. So what I'm going to do is I'm going to say load space joy.bass. I should be able to list that, and there is a program. So you can see here where it's D-write and D-read. So these are actually reading the pins. So those pin numbers 10, 9, 8, 12, 11 that we talked about. And if it detects something, it'll print out an input. And that's actually how in BASIC you actually write a driver to detect the joystick and do something with its inputs. So let's run that program. Typing run. And you'll see it actually brings up a small window space, and that's because this is a Rio Shell program. Now, if I grab the joystick and let's try inputting a few inputs, and let's see what that does while the program is running. So you can see it's actually detected up, left, right, down, and fire. Up, down, left, right, and fire. So that's how we know that our joystick has been successfully wired in, and it really is that simple to add a joystick into Project Rio. And that's one of the little test software programs I have now developed for the system. Okay, so that was a really simple test just to see how well the actual joystick worked. And as you can see, it worked first time. The wiring is really simple. The Atari 2600 standard, although a very old and simple standard, is great for our needs. And you saw the basic code there. It's not difficult to write a driver, if you like, within your existing basic code to actually identify and use a joystick. Also, I found out that the joysticks, because they're not having to be read through a terminal keyboard buffer, actually work quicker and are more responsive than what we're getting on the keyboard. We're getting a bit of lag on the keyboard at the moment. So for games, especially simple arcade games, joystick inputs are going to be far more superior to keyboard inputs. And that's just the nature of the system at the moment. Things might improve as we go further along. I don't know. I need to work on that. Now, if you've installed the Rio Shell software onto your SD card, we only looked at one little bit of it, which we didn't load inside Rio Shell. We just loaded it separately. Lots of the Rio Shell components can actually load outside of the Rio Shell OS environment. Next time, in part B of this video, I'm going to go into more detail explaining what this new piece of software is, how it works, and what I hope to do with it in the future. In the meantime, if you want to have a play with it yourself, you can. You just have to type chain space Rio and you can go and play with it yourself. However, the next video will be along very shortly and I will go through in more detail exactly what it is and how it works. If you've enjoyed this video or have been inspired to try building a Tiny Basic or Project Rio system, then don't forget to like and subscribe. And also you need to join us on Patreon. It's patreon.com/Wi-Fi sheep. The prices and the tiers required are in the details to this video. So we really do hope that you can join us. We also have a Facebook group, which is on screen now. The address is facebook.com/groups/WFS Tiny Basic, and that is the official group that's shared between the Wi-Fi sheet projects of Tiny Basic computers and also now Project Rio. I'm really excited about this and I want to get something kind of together, so I've got something to show for Going Gooey, our new series, which is building up to this year's Retro Computer Festival in Cambridge. Again, the details for that are on screen. Do go and check that out and it would be great to see you in person. So that's just about it for this part 4A of Project Rio. Thanks so much for watching and thank you for your company, and I'll see you real soon right here on the channel. Until next time, bye for now.